Hello, my dear students. Today, inshallah, we'll study lesson 4 in unit 4, colors of isosceles triangle theorem. Coloring number 1. The median of an isosceles triangle from the vertex angle bisect it and it's perpendicular to the base. As an example here, in the opposite figure, ABC is a triangle in which AB equal to AC and AD is a median. Then AD bisect for the angle BAC. And we can deduce that measure of angle BAD equal to the measure of angle CAD. Number 2, AD perpendicular to BC. Coloring number 2. The bisector of the vertex angle of an isosceles triangle bisects the base and it's perpendicular to it. For example, in the opposite figure, ABC is a triangle in which AB equal to AC and AD bisect for the angle BAC. Then D is the midpoint of BC. So the bisector angle, the bisector angle of the isosceles triangle perpendicular to the base and bisect the base. So D become the midpoint of BC. So BD equal to CD and AD is perpendicular to BC. Coloring number 3. The straight line drawing passing through the vertex angle of an isosceles triangle perpendicular to the base bisect each of base and the vertex angle. Again, the straight line drawn passing through the vertex angle of an isosceles triangle, what happened? It's perpendicular to the base, bisect each of the base and the vertex angle. For this example, ABC is a triangle in which AB equal to AC and AD perpendicular to BC. Then D is the midpoint of BC and we deduce that BD equal to CD. Measure of angle BAD equal to the measure of angle CAD. Okay, now axes of symmetry of a line segment. The straight line perpendicular to a line segment at its middle, it's called the axis of symmetry for that line segment, and it's known as the axis of a line segment. Look at this figure. In the opposite figure, if D is the midpoint of AB and the straight line L perpendicular to the line segment AB, where D belongs to L, then the straight line L is called the axis of symmetry of the line segment AB. Important property. Any point on the axis of symmetry of a line segment is at equal distance from its terminates ending point. Okay? For any point on the axis of symmetry of a line segment, I have equal distance between the two ending points. For this example, if the straight line L here is the axis of a line segment AB, D belongs to L, E belongs to L, and F belongs to L, then DA equal to DB, and EA equal to EB, and also FA equal to FB. Okay, and also the converse of the previous property is true. If a point at equal distance from the two terminals of a line segment, then this point lies on the axis of this line segment. Okay, if I have equal distance, so the point lie on the axis of this line segment. Now, axis of symmetry of the isosceles triangle. We studied before also in primary stage. The isosceles triangle, how many axes of symmetry? I have one only axis of symmetry for the isosceles triangle. Okay, so the isosceles triangle has one axis of symmetry. It is the straight line drawing from the vertex angle perpendicular to its base. So I called here the straight line AD, okay, is the axis of symmetry of the isosceles triangle ABC. For an example, in the opposite figure, AB equal to AC equals to 10. So this isosceles triangle. AP equal to EC, okay, and AE intersect with BC equal D. If BC equal to 6 cm, find the length of CD and AD. Okay, how to find this? Since AB equal to AC at first, then A is on the axis of BC, okay? Since EB equal to EC, okay, then E is on the axis of BC also. Then AE is the axis of BC. Since D is the midpoint of BC and AD perpendicular to BC, since D is the midpoint of BC and BC equal to 6 cm, then CD equal 3 cm. Okay, bisect for the base. Then since AD perpendicular to BC, then in triangle ADC, that is a right angled triangle at D, and we can find AD by Pythagoras theorem. AD squared equal AC squared minus CD squared, and AD squared equal 100 minus 9, because AC equal 10 cm, 10 power 2 equal to 100, and CD equals 3 cm, so 3 power 2 equals to 9. And we answered AD equal square root 91 centimeter. Okay, remember with us. The scalene triangle has no axis of symmetry. The trapezium has no axis of symmetry. And also the parallelogram has no axis of symmetry. Again, scalene triangle, trapezium, and parallelogram has no axis of symmetry. What about the isosceles? I have isosceles triangle and the isosceles trapezium. All of them has one axis of symmetry. Okay, the isosceles triangle and the isosceles trapezium has one axis of symmetry. Okay. Also, the rectangle and the rhombus has two axes of symmetry. Equilateral triangle has 3 axes of symmetry. The square has 4 axes of symmetry. Regular pentagon and the regular hexagon, okay, regular pentagon has 5 axes of symmetry and the regular hexagon has 6 axes of symmetry. What about the circle? Circle has infinite number of axes of symmetry. So, scalene triangle and scalene trapezium and parallelogram has 0. Isosceles triangle and isosceles trapezium has 1 ax of symmetry. Rectangle and rhombus has 2 axes of symmetry. Equilateral triangle 3. Square has 4 x's. Regular pentagon has 5. Regular hexagon has 6. And the circle has infinitely number of x's of symmetry. Okay, now choose the correct answer. Number 1, the triangle which has no axis of symmetry is called isosceles triangle. The triangle which has 3 axes of symmetry is called what? 3 axes of symmetry, it's called, yes, equilateral triangle. The isosceles triangle has what? Has only 1 axis of symmetry. If the point A lies on the axis of symmetry of xy, then ax and ay, I will choose congruent because here I have ax at the line segment and ay at the line segment. Okay, pay attention, this is ax at the line segment and ay at the line segment. So I chose congruent, not equal. Okay. Number 5, if xa equal to xb and ya equal to yb, then xy as a straight line and ab as a line segment. So xy is perpendicular to ab as a line segment. Number 6, in the opposite figure, triangle ABC, AB equal to BC, and altitudes of drawing from B to AC and intersect AC at D, which conclusion is not always true. In this figure, okay, AB equal to BC and D is the midpoint of AC, okay? So BD is the axis of symmetry. So measure of angle ABD equal to the measure of angle CBD. So first one is true. And also BDA equal to BDC equal to 90 degrees because it's perpendicular. So the second one is true. And AD equal to BD, it's right? No. So number C is our choice. At the end, thanks for your listening, my dear students.